For the assignment, make sure you ask questions. All right. So, let's see. 1, 2, 3, and 4. We just want to know if it is a function or not. Okay. So the main thing is does the x value repeat? If it repeats, it's not a function. The y values can repeat and still give you a function. Y values repeating, if they all repeated as a horizontal line, x values repeating as a vertical line. Vertical lines are the only ones that aren't functions. Okay? So yes, no is the answers there. And then 5 and 6, yes, it's a function because none of the x values repeat. You have 2, 3, 4, and 5. Those are the x values. They don't repeat. Number 6, it looks like the 3 and the 3 on the first and last one happen to repeat, so that creates not a function. And what was the test that we can look at if we have a picture, if it's a function or not? Vertical line test. Okay. So is 1, 2, 3, 4, 5, 6 okay?
Yeah.
And then 7, 8, 9.
What does 9 say?
I think it's a no. Let's hit on down. All right. So 7, 8, 9, and then 1, 2, 3. Who knows why that's that way? Vertical line test. I mean, that's really all the vertical line test is. Draw a vertical line. If you can show that it touches the graph twice or more, it's not a function. So 7 is not a function. 8 is, though. 9 is not, so circles aren't. Yo.
If I wrote function and non-function instead of
Perfect. Love it. Love it. Yo.
What is the difference between 3 and 7?
Okay. So I can draw a whole bunch of vertical lines right here, and it only touches once. So that's a function.
Oh, okay.
That's not, even though it's a sideways parabola versus up and down parabola, the sideways one, because the x values would repeat. Now on number 3 though, the y values will repeat.
And what's up with the numbering?
We're math teachers, we can't count. Yo.
You're saying they will repeat, and it's because they're not in that little. So 7 y repeats.
The x repeats on. So on number 7, if I came over to where this line's drawn, it looks like 1, 2, 3, 3.5. So 3.5, comma whatever, 3.5, comma whatever. It happened twice, so it repeats. The x repeated, so it's not a function. But if I came over to say this one, this would be say the point -2, 0, and 2, 0. -2 and 2 are two different numbers. So vertical line test, x values repeating. If x values repeat, not a function. If they do repeat, not a function. If they don't repeat, it can be a function. All relations are functions. Oh, wait. All functions are relations, but not all relations are functions. What was a relation? What did we say it was? What did I say it was? I forget. What's a relation? What? No? Relation. Yeah.
Relation is when isn't it like when the x has the same number as the rest?
Could be. What was the definition of relation? And? So a function is a relation where the x values don't repeat. So what is a relation? Yeah.
Is it a relation like when it's like an x value?
It could be. Yeah. Could be. What's a relation though? Going back a smidge. Real easy. A relation is just x comma y. So if you have a set of points, that's a relation. In order to give it a specific name, though, to call it a function, the x values can't repeat. So if you have a whole bunch of sets of ordered pairs, it's a relation. If that set of ordered pairs doesn't have any repeating of the x values, it's also a function. All right, 10 and 11. These are kind of you fill in your own. So create a relation that is a function. So problem number 10, I put The x values is 1, 2, 3, 4. The y values is 5, 6, 7, 8. It could have been anything, any sets of numbers, as long as the x values did not repeat. But problem 11, I had 1, 1, 2, 3, and then 4, 5, 6, 7. Being there's a set of x's that are the exact same. Okay? So again, those could have been any answer. So if we asked you out on a test, hey, create a relation as a function, you could be picking up some huge obscure numbers as long as they all are all different. They could be decimals, they can be fractions, whatever. All right. So let's just talk about number 12. Number 12 is a little different, okay? We didn't go over it entirely, so that's kind of the reason I'm not marking it off today, because I didn't cover really this. But I want you to feel good about how they work, okay? If the input's -3, that means I'm taking -3 and plugging it in for x. So I get -2 times -3 minus 7. You do the math, it comes out to -1. So by plugging -3 in for x, I get -1 out, and that yields us a point -3 comma -1. But then the next one where you have 21 where the output is, that means that's my y component. So you put 21 in for y and you solve for it. So you get 21 equals -2x minus 7. Do the two-step equation, add 7 divided by 2, and we realize that the answer comes out to -14. Okay? And that yields me the point -14 comma 21. And then the input is 0, so I'm plugging 0 in for x. So I get -2 times 0 minus 7. That gives me an answer of -7, so 0, -7. And then the next one, I have 14 I'm plugging in. Oh, Nikes, I made a mistake. I plugged 14 in, that should go in for the x, so that's -28, -28 minus 7. That should have been -35. I can't erase it. Should have been -35. Because it should have been -2 times 14 minus 7, which gives me -28 minus 7, which -28 minus 7 is -35. Sorry about that. Can't move. Okay. All right, and then 13 and 14. Some of this might be common knowledge, some of it might not. Okay, it says for the following graphs, give the domain and the range. Okay, so that's the first thing we'll answer. This is give the intervals on the x-axis where the graph is decreasing, and give the intervals on the y-axis where the graph is positive. Okay, so watch. A few things I want you to get terminology down. Does this line go forever in the x and the y direction? There's no break in it. It doesn't go and change directions, correct? So the domain, this is the x values. Okay? So if I were to go this way forever, is there going to be a y value it's going to go to?
No.
So this line is going to continue this way. Do you agree? So if I continue along this line in the x direction, will there be a line above it as I continue this way? The arrow at the end of the line means what? The what? Yeah, this means it's going to go forever. This means it's going to go forever. So if I go forever in the x direction this way, there's going to be a y component to it. What about if I go forever this way? Is there going to be a y component to it? Yeah, it's going to be way down low though. Okay? So the domain is going to go from -infinity to +infinity. Meaning, if I were to go in the x direction forever and ever and ever and ever, my y component is going to be a really large number. If I go to +infinity, my y component is going to get to be a more and more negative number because it's going downward. Okay? So the domain goes from -infinity to +infinity. The range. Does this graph go forever downward now?
Yes.
Does it go forever upward here?
Yes.
So the range goes from negative to +infinity as well. Okay? Give the intervals where the graph is decreasing. This whole graph, all of it, is decreasing. Okay? It's starting way up here. It's heading way down here. The whole thing is decreasing. So it's decreasing with no increasing. Where are the intervals? So it decreases from negative infinity to positive infinity. Okay? So starting in the x direction, as I go way out to negative infinity, forever that way, and then I go forever this way, the graph itself is decreasing. The numeric values as you go to the right in the y direction are decreasing. Where is this function? Give the intervals of where this function is positive. Well, is positive increasing? I'm going to tell you right here, this portion right here, it's all positive. Why? What's it above? The x-axis. Wherever our graph is above the x-axis is where it is positive. Okay? So, it is positive from negative infinity, way this way, all the way up to, that's the 0.6. It's above the x-axis. If I were to plug an x value in on values that are from negative infinity to positive 6, every one of those answers is going to give us a positive answer. As soon as I go beyond 6, I get to 6.0, infinite O's with a 1, that gives me a negative y component. So where's the positive? Positive values are above the x-axis. That's a big concept to see. Okay, so now this next one. Give the domain and range. Okay, the domain. I go from here all the way to there. So I go from 0 all the way to 8. Flip flop my answers. Sorry. So from 0 to 8, 1, 2, 3, 4, 5. All of those numbers, that's my domain. Okay? My range goes from here all the way up to here. So my range goes from 0 to 6. I don't know how I flip-flops. Sorry. Done it too quickly. Okay? Domain x values. Where do the x values exist? They exist starting at 0. They go all the way to 8. Okay? Does this graph that has drawn right here exist over here at all? I don't see it, so I don't think so. Does it exist anywhere beyond this point? No. So where does my domain exist? Between 0 and 8. 0 and 8, the x direction is where my graph happens. It doesn't happen anywhere else in the x direction. Where does it happen in the y direction, the y component? It goes from 0 all the way up to 6. Okay? Where is this graph decreasing? Right here it's decreasing. So from 3 all the way to 5, it's decreasing. It's also decreasing right here. Okay, which is 7 to 8. So it's decreasing at those values. Where is the whole thing positive? Is the whole graph above the x-axis? Is some of it below the x-axis? It's all above. So it's positive from 0 to 8 in the x directions. This is going to make it all positive. All of those values, I plug in one of those numbers, one of those decimals is in between those numbers, one of the fractions that are in between 0 and 8. It's going to give us a positive amount. Okay, that's a little different thought process that we're getting to. And what this will eventually get to is something called a sine line, which is a linear line of the x-axis, and it tells you, as you progress along it, where do you have values above and below the line, or where they're positive and negative. Okay, but we're not there yet, but we'll be getting there. So it's a little different concept to think about. Whoop. Cleared the ink. All right. Now 15, 16, 17, 18, 19, 20, 1, 2, 2, 3, 24 are all done the same way. So if you have F at 3 or G at 3 or H at 3, sometimes they hear it as F of or F at. It's both is how it's stated. So you choose which way you're going to do it. This means when you have it like this, you plug in to X. Okay, you find your F equation. Here's my F equation. I'm going to take negative 3, plug it in. Negative 3 times negative 3 is positive 9. Jeez. I'll tell you, I'm making all kinds of errors, which gives me an answer of 13. Sorry about that. F of 5, I'm using the F equation. So I'm going to plug 5 in. Negative 3 times 5 is negative 15. Negative 15 plus 4 is negative 11. If I plug 0 in for G, I'm no longer using the F1, I'm going to G. Okay? I'm plugging 0 in. 0 minus 3 is negative 3. Negative 3 squared is 9. 2 times 9 is 18 plus 1 gives me an answer of 19. G, I'm using my second equation again. It's telling you which equation to use. I'm going to plug 3 in. 3 minus 3 is 0. 0 squared is 0. 2 times 0 is 0 plus 1 is 1. And then it says, hey, use H equation. That's my next equation is using H. Okay? Notice the different letters. F, G, H. We have F, G, H. Functional notation is F at or F of or G of or G at or H at or H of. Okay? It switches out with Y. It's called functional notation. You're writing it as the function at a certain value. Okay? So number 19, I'm using H. So I have 5 times 2. 2 happens to be, this is an exponent. So 2 raised to the 0 power is 1. Okay? 5 times 1 is 5. Which equation am I using here? The first, second, or the third? The third. Why is that? It says H. I'm using H. So I have 5 times 2 raised to the third power. Okay? 5 times 2 raised to the third power. Order of operations says to do what? Exponents first or multiply first? Exponents. Okay. So 2 to the third power is how much? 8. 2 times 2 is 8. And then 8 times 5 is 40. Okay? Number 21, I'm plugging negative 3 into which equation? The first, second, or the third?
First. Wait, what?
First. Why is it the first? F. Okay, so F at negative 3. I'm going to take negative 3, plug it in for X on my first equation. Okay, 3 times negative 3 is positive 9. Positive 9 plus 4 is 13. Problem number 22, which equation am I using? The first, second, or third? Second. Why? It's a G. So G at negative 1. Plug negative 1 in, so I get negative 1 minus 3. That's negative 4. Negative 4 squared is 16. 16 times 2 is 32. Plus 1 is 33. Number 23, am I using the first, second, or third equation? Third. Why is the third? Because we're using H. Okay, so I'm taking 1 and plugging it in for H. So I have 5 times 2 raised to the first. 2 to the first is 2. 2 times 5 is, and there you go. And then F at 2, am I using the first, second, or third equation? First. Okay, so I'm going to plug 2 in to X. So 3 times negative 2 is negative 6 plus 4. That gives me an answer of negative 2. Okay, so functional notation, if you see F parentheses number, or H parentheses numbers, or G parentheses of numbers, that means you're substituting in for your X value. All right, so let's take one leap that wasn't on here. This means this yields me the point negative 3, 13. This yields me the point 5, comma, negative 11. What does this yield me? What point? 0, comma, 19. What does this yield me? 3, comma, 1. What does this yield me? 0, 5. What does this one give me as a point? 3, comma, 40. What does this one give me? comma 3, comma 13. What does this one give me? Negative 1, comma 33. What does this one give me? 1, comma 10. What does this one give me? 2, comma negative 2. Okay? So we're talking about points. If there's points, we can graph it. Okay? We're not there yet, but I just want you to understand. If you plug an x value in, that is your x component. The output that you get is your y component. But what's going to be different about 25, 26, and 27? Am I plugging a number in for x? Am I plugging a number in for x here, or here, or here? No, I'm plugging a number in for this, or this, or this. So, first one, when f at x is equal to 22, so I'm going to go 22 equals negative 3x plus 4, then I'm going to solve it. Subtract 4, that's 18, divided by negative 3, that's negative 6. Hey, what point does this yield me? Be real careful. What point does this yield me? Between this and this. How much?
22.
What is x equal to? What value comes first in as a point? X. So what's this point? 22. There you go. Okay, so you're using the output to get the input now. So now I'm going to use the third equation, h at x. So I have 20. So I have 20 is equal to 5 times 2 raised to the x. Okay, we're going to do our reverse operations. So I would do exponents first normally, and then multiply, and you have to go reverse of that. So I'm going to divide by 5. That gives me 4. 4 equals 2 to the x. 2 to what power gives me 4? 2. What point does this give me? 2, comma 20. Exactly. Okay? Number 27, we're using g, so we're going to use this equation. So I have 33. So 33 is equal to 2, x minus 3 quantity squared plus 1. Okay? So order of operations would suggest to do the exponent first, the multiply second, and then the add subtract third. But you have to do it backwards to solve it. So, God bless you. I'm going to subtract 1 here. That gives me the 32. I have to divide by 2 here. That gives me the 16. And then I have to do the root and the root. And remember, if you do the principal square root, it gives you 2 values. It's related to the absolute value. Okay? So that gives me the principal square root of 16 gives me a positive and negative 4 for an answer. So then I need to solve that. I'm going to add 3 to get x by itself. 3 plus 4 is 7. 3 minus 4 is negative 1. This gives me 2 points. What are my 2 points? What's one of them? Comma? Good. 7 comma 33. What's my other point? Perfect. Negative 1 comma 33. Hey, question for you. Looking at that, do you think it's a function?
Yeah.
What?
No.
Yes. Why?
Oh.
What doesn't repeat? The x. What does repeat? The y. Is it okay for the y to repeat and have a function? Yes. I continue to say, if the x repeats, no function. If the domain, which is the same thing as the x, repeats, no function. If the domain, which is called the input, which is called the x, repeats, no function. The y, the output, the range, can indeed repeat to give you a function. Holy moly guacamole. I feel like I decompressed a whole lot of stuff real quick. So, the notes today are pretty simple, and it's only a 1-page assignment, which is really awesome. Okay. All right, so, can I get rid of this? Gone. All right. All right. All right. Shh. Function at 7. In your opinion, what does this mean? What does this mean if I have an equation? What should I do with 7?
Can't repeat it.
F at 7. Function at 7. What do you think it means, Ben?
You can't repeat it.
Could happen.
You plug
Well,
it into something.
Where am I going to plug it into? I like it. Yeah. So let's say that we know f at x is equal to, I don't know, 3x plus 4. Where is 7 being plugged into? It's being plugged in for x. So you get 3 times 7 plus 4. So that's 21 plus 4, which is 25. What point does this yield me? 7 comma 25. Awesome. Okay? Now, let me go the other way. If I know that the function at x is equal to 30, where am I plugging that 30 in? Am I plugging it in for an x or not?
30 equals 3x.
Was that?
30 equals 3x.
There you go. So, being that the function at x and the function at x is equal to this, and then we know it's equal to this, that means I'm going to take 30 and plug that in for that. So I'm going to get 30 is equal to 3x plus 4. Algebra 1, right? Second week. So I subtract 4 from both sides. So with me? What's the last step? Divide by 3. If it doesn't work out nice, keep it as a unlucky, ugly looking fraction. What point is this?
26 over 3.
Yes. There you go. 26 over 3, comma 30. Okay? So, this is an x value. This whole thing is a y value. So y equals functional notation. They interchange back and forth, back and forth, back and forth. Why do we do it that way? Because sometimes we want to know what the function at a certain point is equal to, while other times we just want what the equation is equal to so we can graph it. Okay? I want to do this one more time. Can I do that? Yeah. Okay. Clear ink. Let's say we have a function at 10. 10 is what kind of value? X or y? Function at 10. 10 is an x or a y value. X. So this right here is going to yield me 10 comma some number. Got it? So let's say we know that we have a function equation to be that. So what am I going to do with the 10? I'm going to plug it in for x. This is going to get plugged in right there. So what point does 10 yield me? 10 comma 64. There's a point. What if I knew this? What is the 8 now?
8 equals 7x minus 6.
Okay, and what is it? X or y?
X.
No, it's the y.
X is here.
It's the y.
That's y. So now I'm trying to plug that in. So I'm going to substitute 8 in for this. So I'm going to get 8 equals 7x minus 6. Add 6. What's x equal to? 2. Two different ways to write this. Be very cautious when you're going through them, okay? What's this other answer going to be? Output. What's this other answer going to be? Notice an ordered pair, a relation, x comma y, can be written as x comma y as a point. It can be written as input output. It can be written as domain range. Function at x and an answer. Okay? I don't want to go there yet. I'm going to reset for now. I don't want to go there yet. So those are a few things just to know. Know that x goes with input. Input goes with domain. Domain goes with x. Y goes with output. Output goes with range. Range goes with y. Okay? Oh, whew. I think you guys are all ready for worksheet number 5B. Okay, I think because of we have covered enough now that you are able to do that one-sided page to be checked off for tomorrow. I would take the next 15 minutes, get it done. You get it done, guess what you go home with? Yeah, well, no homework for this class. Don't let that count for. Sweet, no homework in English, social studies, PE. I got to bring my socks. Right? Do great.